Hello. In this video, in the previous video I said we'd be working backwards, but I want to clarify that. Instead, we'll be looking at using the binomial distribution, and this is for learning intention 42. But instead, I want to clarify how to use the cas here. So we're going to look at a binomial distribution, and I'm going to show you two cas functions which you must know. So let's consider a coin toss, and let's say, well, it's a binomial because there's success and failure. Let's say we flip a coin 4 times, and we know that the probability of getting heads, which we're going to define as success, is half. So heads, flipping a heads equals success. So we have our discrete random variable, and we're going to do 4 trials, and the probability of getting a heads is a half, and we're going to say that means we're successful. What I'm going to do is actually plot this. So how do you plot a discrete random variable? Well, let's plot a discrete random variable. What's it going to look like? Well, on the x-axis, you're going to have your all the possibilities, and on the y-axis you're going to have the corresponding probability. So you can get 0 heads, 1 head, 2 heads, 3 heads, 4 heads. So that's x, and then on the y you have the probability that x equals x. So what's the probability that each one of these occurs? So let's pretend we didn't know anything about binomial distributions. How do we work this out? We'll use a tree diagram. Let's use a tree diagram. You would go heads, tails, heads, tails, heads, tails, heads, tails. I want to emphasize how good the binomial distribution is by making you draw a tree diagram again. I think that's important. Heads, tails, heads, tails, heads, tails. It's getting very messy here. It's tails, heads, tails. Alright, so you're going to have heads, 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 tails, heads, heads, tails, heads, 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 tails, tails, heads, tails, heads, 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 tails, heads, tails, heads, tails, tails, heads, heads, tails, 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 heads, 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 tails, heads, heads, tails, tails, heads, tails, heads, tails, heads, tails, 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 heads, heads, tails, tails, heads, tails, 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 heads, tails, 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 tails. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Look at all that. Oh my. Not pretty. Alright, well, what's the probability of getting no heads? That's tails, 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 tails. So that's 1 in 16. So let's graph that. So it's just like 1 in 16 there. What's the probability of getting 1 head? 1, 2, 3, 4, 4. So 4 in 16. So 1/4. So it's going to be like there. There's 1/4. Probability of getting 2 heads exactly. 1, 2, 3, 4, 5, 6. So we do that. So that's going to be 6 out of 16, which is 3 out of 8, which is very close to a half. So it's going to be like there. 3 out of 8. 3 heads. Well, let's count that one again. 2 heads. I'm a bit skeptical. 1, 2, 3, 4, 5, 6. Yeah, 6 out of 16. 3 out of 8. Okay, 3 heads. 1, 2, 3, 4. We've got 4 options there. Let's count again. 1, 2, let's see, 1, 2, 3, 4. I can't see anymore, so that's a quarter. And 4 heads is 1 out of 16. So you can see it's symmetrical. That's nice. Would they always be symmetrical? Well, have a go. Come up with a different one. Change the probability to not a half. See what happens. See what happens there. Now, here's the sweet part. Here's what the CAS can do for you. You don't really have to do this, because if you want to find the probability of getting exactly 3 heads, there's a CAS function you can use. Now the one you're going to use, the way you're going to find this is by using Binomial PDF. So probability density function, probability distribution function. What you do is you put in the number of trials, the probability of success, and the X value you want. It'll give you the answer. Let's get out our CAS. Let's see if that's true. Binomial PDF. You can go to the menu and find it, but I'll type it this time. Binomial PDF. So we've got 4 trials. Probability of success is a half, and we want to know what's the probability of getting exactly 3 heads. 0.25, 1/4. That's nice. That saved us a lot of grief. Look at all this work. Your CAS can do it with this. You can find the probability of getting 0 heads. Let's get out our CAS again. Binomial PDF. So 4 trials, 0.5. What's the probability of getting 0 heads? 0.0625, which is 1 on 16. Sometimes I ask for decimal for these. Alright, what's the probability of getting 4 heads? Let's practice again. Make sure you practice using that CAS. PDF 4.5, and was that what I wanted? Was it 3 or 4? 4, yep. 4 heads, 1 on 16 again. Beautiful. So that's Binomial PDF. That tells you the probability that the discrete random variable takes on a particular value. What if I wanted to know the probability that x is between 2 and 4? What if I wanted to know the probability of getting at least 2 heads? I could work out each individual one and add them together, but there's another function for that. And I showed you in the previous video. It's Binomial CDF. And you just put in your range there and it does it for you. So let's try that. Well, let's see, what do we expect the answer to be? So it's going to be 3/8, which is 6 on 16, plus 4 on 16, which is 10 on 16. So we expect it to be 11 on 16. But let's check with our CAS. So this is cumulative. Cumulative means you keep adding. 4, 0.524, so you put in the range. Let's check it. 11 on 16. Let's see if that gives us 0.6875. Beautiful. 0.6875. 11 on 16. Let's try another one. So what if I wanted to, okay, here's one you should all be able to get. What's the probability that it's between 0 and 4? What's the probability that I get between 0 and 4 heads? Pause the video, think about the question before I put it in the CAS. Alright, here's the answer. Let's do it. Binomial CDF 4.5, 0 to 4. Of course it's 1. It's 1. Because you're guaranteed to get 0, 1, 2, 3, or 4 heads. That's all the options there. So the key takeaways here are how to use each of these CAS functions. And if you have been, thanks for watching.